When you turn on your computer, the process starts with the power supply unit, or PSU, which converts electricity from your outlet into the appropriate voltage levels for the motherboard and other components. This triggers the motherboard to power up, and the system enters the first phase controlled by the firmware, BIOS, or Basic Input-Output System, or UEFI, which stands for Unified Extensible Firmware Interface. The firmware initializes by performing a power-on self-test, commonly known as POST, which is a series of diagnostics to check the hardware's health. It ensures components like the CPU, RAM, keyboard, storage drives, and graphics card are functioning. If something is wrong, you'll get a beep code or error message. Next, the firmware accesses configuration data stored in CMOS memory for BIOS, or UEFI's non-volatile memory, which contains settings such as the boot order. The firmware identifies the first bootable device, often your hard drive or SSD. At this point, control is passed to the bootloader, a small program stored in the boot sector of the drive. If the system uses an MBR, or master boot record, the bootloader is found in the first sector of the disk. For GPT, or GUID partition table, the process involves a UEFI-defined method. The bootloader, such as GRUB for Linux or Windows Boot Manager, loads the operating system's kernel into memory. The kernel is the core of the OS, responsible for managing hardware and software communication. Once the kernel is loaded, the OS initializes device drivers, which are software that allow the OS to communicate with hardware components like your mouse, keyboard, and display. As the system processes start running, background services and daemons, programs that run in the background, are initiated. These include networking services to establish Wi-Fi or Ethernet connections, security services like antivirus or firewalls, and system health monitoring tools. The OS also starts system-critical processes, like those managing file systems and graphical interfaces. Once these steps are complete, the OS presents you with a login screen. Here you authenticate yourself, typically with a password, PIN, or biometric data. After logging in, the OS retrieves your user-specific settings and preferences, loads your desktop environment, and starts any programs you've set to run on startup. At the same time, it finalizes hardware configurations, making peripherals like printers, external storage, or additional monitors ready to use. With all these processes complete, your system is fully operational. You now have access to the desktop or command line interface, your applications and files, allowing you to begin your tasks. This entire sequence, although highly complex, happens in seconds thanks to the efficient coordination of hardware and software.